welcome to another video where I got recommended this video, Shane versus an entire Discord server full of hardcore globies on gravity. Now this, I made an exception here, I actually watched this video in advance, and I can tell you that not only are they not hardcore globies, they have little more clue than you have, which is fine, you know. Not everyone needs to have an understanding of physics, which is completely fine, but then to go on and make claims about it, that is not fine. And actually I will show today how Shane not only has no clue, like whatsoever, right? And actually on a couple of occasions plays into my hands, or our hands really, the hands of reality. He uses globe numbers without knowing. And this is fun, because I can derive the globe numbers only from other globe numbers. So yeah, we'll have fun today, I can tell you. This is a good one. So let's go ahead.
Let me clarify, you don't believe in gravity? Is that it?
But it does. No, I totally believe in gravity. I totally believe in gravity. You guys don't believe in gravity? You don't believe that like you can kinematically derive gravity from just basic function of time and height?
You cannot derive anything from just time and height. You could derive a general falling rate, like a general falling acceleration, which you can do, which is fine, but you can't really. That's not a big step ahead. You would need to know either big G or the mass of the Earth to get the other. So this is not particularly helpful.
What?
So there's already is already misrepresenting the globe model here.
I want to see one of you all
But we'll get into a lot more detail, don't worry.
kinematically derive it. I want to see one of y'all take math on paper and do one of those kinematic derivative equations.
I would also love to actually see that. Now he thinks that he does that, but he really doesn't. It's so embarrassing.
So it starts cold minded man, right? It starts with something called,
Find it anywhere online.
guys, height equals 1/2 AT squared plus VT, right? Height
I will go into detail about all of these. I will just let him talk now, and then I will go through the claims. Okay?
height is something above the ground. A was called the acceleration downward. T the time for something to
gravity.
hit the ground.
That A
V
is
for the
gravity.
initial velocity. Shut up and let me go. I know you don't. You said I can't do this, so let's go ahead and listen to me do. I know it's painful. Let's
You got
start and
an A in there,
simplify
it's
with
gravity.
velocity.
I need to actually correct this dude here. No, A is not gravity. This is a general formula for all of for everything that is constantly accelerated, uniformly accelerated, we say in physics. So no, A here is not. I mean, it is, but it not necessarily, right? So the dude here is wrong.
V equals 0.
using
You got height
gravity.
equals 1/2
Hey,
acceleration.
Samantha, fucking wait.
1/2 acceleration times squared. Simplify it. You got A equals 2 times height over time squared. Let's say drop a ball from 10 meters. Takes 1.43 seconds to fall. You got A.
That's very correct. He doesn't go into the reason why, and that's the big thing. He would need to explain why a ball falling from 10 meters takes 1.4 roughly seconds. He doesn't. His model can't explain that. Ours can. I will go into a little bit detail how it does that later.
equals 2 times 10 over 1.43 squared, giving it roughly what, 20 over 2.0449, giving it A equals 9.78 meters per second, right? So that's pretty close to deriving it on the spot. No big G required. If
Ouch. We will. I love it. He uses. Okay, so the thing that he does here is he uses a real world observation, the falling of an object, because the numbers are spot on. An object falling from 10 meters will take 1.43 seconds. You could just use 1.4, it's close enough. Seconds, right? And so, which is due to gravity. And then he puts it into that equation and says that, well, no big G required. But the numbers are the way that they are because big G is the number that it is. So he's kind of really totally avoiding the finger, but he's using globe numbers, and they will show how he's doing that just in a bit.
you want to get into the causality of big G, we have, of course, our better argument for electrostatic downward gradients causing the non-zero
I will also talk about that. It's complete crap.
vector, right? Vector, of course, meaning it has to have a
This thing on the left here does not pertain to really much of anything about his argument. This is a calculation of some flux through a given electrical field in a particular direction. Has absolutely nothing to do with what he's claiming. I love it. It's funny. This one here is correct. I will go into more detail about this one on the right here as well.
Magnitude and direction, the vector being caused by the voltage gradient present.
Yeah, that's from the Feynman lectures. I will link them in the video description below, where they also talk about how this changes throughout the day, how it changes with weather, and how particularly it reverses during a thunderstorm, completely demolishing what you say here. But I will also do that later.
And on the
Don't
Earth
worry.
from the two different states of our charge distribution hemisphere called, the Gaussian surface being the firmament, and our positively charged
Citation needed.
Earth. Sorry, negatively charged Earth in your world, right? Negatively charged Earth, positively charged.
Bulk matter is neutral, so no.
Stop. Charge and discharge, whatever the two states are seeking equilibrium, those two opposing surfaces creating the voltage gradient, expertly creating the downward voltage gradient that would determine the general direction of down for every.
No, it wouldn't. It would only determine the downward vector for charged objects, or objects that have at least a dipole. Yeah, which not all objects have. And it also would immediately impart a force on these objects depending on how charged they are. But all objects follow the same rate, independent of material, so it's complete crap.
Everyone, and then you have
Also, this layering here doesn't occur like that. There's a mixing below 90 kilometers where it's essentially uniform. Above 90 kilometers, this mixing happens, but is again completely explained by the globe alone, so no need to have an electric field here. Particularly because, like, that's not the order of electric charge. First of all atoms are neutral. Well, not all, but like in the far majority will be neutral. And the ones that actually are charged, I would expect hydrogen to be because it has the highest charge to mass ratio. Because if it loses one electron, it has a charge of 1 elementary charge, but also a mass of like 1 nucleon. So it would be the highest. So it should actually be down here. Let's not
density,
go into
buoyancy, and viscosity, doing the general work of what you have previously attributed to big G. How are we doing so far?
very bad. It's so many words that are backed by absolutely nothing. That are I wouldn't even dare to call it speculation. It's more like making it up on the fly using words that hopefully confuse your opponent, which in that case actually more or less works.
I think that's about the saddest attempt to sound intelligent.
That's true, though. It's very sad.
Yeah, so you
Very
didn't
sad.
understand any of the words without saying
Oh
it.
no, I followed what you said. It
Well,
just
no, can we-
doesn't make any sense
Can we?
because you
So,
didn't say
Yeah, can we get it written down?
Here he has an example, actually. And the thing that bothers me here is he does not explain why the time and the height are the way that they are. And of course you're going to get roughly 10 meters per second squared, because this is what you can derive from only the gravitational equations that we use in mechanics. And I will show that again. I will show all of that. Don't worry. I'll just talk now. I'll show all of that later.
Hey, can we get it written down so we can actually like review it? Like I can't follow. Like first off, I can't follow any of that math, and it's hard to even see. If you.
No, nothing of that is wrong. It's just he doesn't he doesn't provide an explanation of why this contradicts what we say and why this agrees with what he says. He doesn't do that. He just shows the numbers and it's like, yeah, it works. Of course it works.
You are,
It's so embarrassing. He really has no idea how to do this in the first place. This is about the middle school level, I think. Things may be different from the US to Austria, right? But
if other people can follow it. Right now, it's
Sounds
just
like it's
can I remember what you're saying? So
Oh,
I don't know.
you guys act like
hold on a
I don't-
second. NASA's muted. Hold on.
You guys act like I don't
I
publish
think
this in my
NASA wants to
database.
go through the math with you.
Yeah, he's using gravity. That A that you're using is
I will also talk about buoyancy, by the way.
gravity. 9.81.
The A is not gravity. A is just a general term for acceleration. in this case it is due to gravity, but not necessarily A is gravity. Not even small g is not necessarily always gravity. It's just a number, right? It's just a name for a number, really.
1 meters per second downward. Thank you very much.
You guys act like I couldn't derive it on the spot. Sure.
Well, you can't. You showed a kinematic equation. That's it. And you plugged in the numbers. You had no... Why would your thing agree more with it than our thing? You have not answered any of them. Not answered any of them. You said that the that your electro model thing would work better without providing any evidence of that. So it's just an empty statement, really. It's because you can't. That's the thing.
You didn't. You
guys
used
act like
gravity.
I don't know what it is. Sure do. You guys like have a causal mechanism that's experimentally proven. You sure don't.
Yeah,
However,
you see that A?
when you said where's it
Hello?
coming from?
Hello, you
Right?
see that A?
Here's where it's coming from. Here's the math. Here's the math. Of course, it's written.
That's not where it's coming from. The fact that you think that that's where it's coming from is telling. You did not look it up, like even for a second. We do this in the first month, I think, maybe the second month of Intro to Physics in university, and you could easily do all of that with high school math.
Written down. You act like
And physics, of course.
I don't have it published on a giant fucking database that I keep trying to have everyone read that no one ever goes. And
Yeah, you see that A? That A is called gravity.
That is not true. That A is not called gravity. That A is just a general expression for acceleration.
That's the acceleration downward, gravity.
so
It is due to gravity. He's right, but it's not, in that case, not really helpful either way.
gravity is simply a function of height and time.
That's not true.
Gravity can be derived by, measured by
That's correct. It can be derived, and I will do so.
height and time. Yes, that's how you do it. 9.81 meters per second per second.
Thanks, kiddo.
So thank you for using
well, hang
gravity
on.
in trying not.
I will talk about all of these things.
I just want to say this real quick. If you guys are willing, Shane, I can put the whiteboard up.
There isn't much more coming here, so I think I'll just cut it short. He's just talking about, well, you know, you have these things, and then at the end they show, I believe that's from Austin's funny little Van de Graaff machine that has nothing to do with what they talk about, because their position, depends on who you ask, is that the electrostatic field only sets the gradient, and the other thing is due to buoyancy. So this would go against that either way. Also, you can only lift up light objects. I would love to see Austin actually levitate a piece of lead or something like that. Now, enough of this video. Let's go over to the presentation, shall we? Okay, so here we have the presentation. I will go through so many lovely things with just a couple of numbers. Not things that you learn in high school, but that you really learn to understand and apply, I think, confidently, at least in my case, in the very early weeks of university. So, yeah. Let's go on. What will we do today? First of all, I would love to show that Shane has no clue what he's talking about, like none at all. It is just astounding. I will disprove all of his useless assertions. I will even make cases for him. I will prove his argument before disproving it, right? Because he couldn't do it himself, obviously. I will give numerical examples for the things that I do, and I will actually show how it fits with globe predictions, which is extremely funny. Okay, let's begin. Some mechanics. This is the general education part of my videos. You can get the equation that he used or partially used from taking, well, acceleration is acceleration, big fucking surprise. Pardon me for swearing. And then you you integrate both sides. You call the left side velocity, kind of based on, we give it a new name, and on the right side you actually do the math. So you say the integral of a dt is at plus some constant. I call this v0. This is the velocity that already kind of the starting velocity, if you will, the velocity that's already there before you do your calculations. Because if there is one, of course, you need to take it into account. For our example later, we don't need to use that, but just so you get the most complete picture of what's going on. And then we do the same thing again. So we say x, we call it's the distance. We say x is the integral of v, and then we integrate it, and we end up with at squared half plus v0t plus x0. X0 here again is just the starting position that's the thing already has prior to our prior to whatever we're doing. And I find it interesting that Shane only uses the first two terms, because normally the way I'm used to it is either you use all of these starting terms or none of them, but he just uses the velocity to not use it anyway, which to me is weird and inconsistent, but sure, whatever. In German, those are actually called the allgemeine Bewegungsgleichung, which means general equation of motion, which I find interesting that it isn't called that in English. I learned that today. I learn something new every day. This is what I learned today, so apparently it's not a thing in English. In German it is, but okay, sure. Now, don't be scared, it's really easy. Shane is correct when he says that the acceleration is the same as 2 times the height divided by the time squared, supposing that there is no v0 or x0, of course, which is a reasonable assumption to make when you let something fall. And so you can say, and now comes the thing. He says that that's how we do it. That's not how we do it. So the way that you actually do it, because he hasn't answered the question, why does it take 1.43 seconds for something to fall from 10 meters? I can answer this question very easily. You say that the acceleration is due to gravity, of course, because that's how it works. And then you can equate these two terms. You can say that 2h over t squared is the same as gm over r squared, which you might know from the law of gravitational attraction. This is the gravitational acceleration, not the force that is usually given. This is the acceleration. You can rearrange this formula for t, which is r times the square root of 2 times the height over gm. R here being your height from the center of Earth, right? And h being the height from which you let something fall. So this is a difference, right? The h is really just the difference, which is you say you drop it from 10 meters to 0, where 0 really should be the distance from wherever it is that this object falls to the center of the Earth, like the center of gravity. But for this case, it is fine to just use h because it's a difference, so you would cut, so it would cancel out either way. So time is the radius of the Earth, roughly. For most locations, this is true enough. Times the square root of 2 times the falling height divided by the gravitational constant big G and over m. You remember when Shane said it has nothing to do with big G? Well, tough luck there, buddy. And you plug in all of those numbers, which all of those are, by the way, the globe numbers. What do you think is the result? Oh, wow. Which is a huge surprise. So this is the first point where I have to say Shane has no clue. So embarrassingly no clue that he used globe numbers without realizing. Absolutely, like that is peak Dunning-Kruger right there. Cool. Let's talk about the electrostatics thing. I love it because it's so blatantly and obviously wrong, but no flat earther seems to understand that, because they have a pre-selected conclusion and they orient their facts based on their conclusion and not the other way around. So first of all, bulk matter is neutral. Full stop. You typically in nature, the more massive something is, the less overall charge it has. This is of course not true if we deliberately charge things. Obviously then it's wrong, but for most everyday objects this is very true. The gradient actually reverses during a thunderstorm, so during thunderstorms gravity should be the upside down. We should all fall up suddenly, which we don't. Also the gradient changes throughout the day. I will have a source for that linked in the description. It's actually the Feynman lectures from which they take their funny graph with the 100 volts per meter, which is correct. What they don't show is that it changes just throughout the day by about 30%, because it would completely ruin the argument. Never ever has a flat earther given a numerical prediction for that. I'm still waiting for all of this to happen, just because they do. So I thought I should do is for these losers. Okay, let's do it. The acceleration based on an electrostatic field is the charge times the electrostatic field divided by the mass. Now the electrostatic field we know is 100 volts per meter. This is the standard unit in which electric fields are given, volts per meter, usually you have all the definitions that work differently, but the current definition, the one that is most widely used, is volts per meter. So we have 100 here. That's cool. We know that our acceleration, which by the way we can derive exclusively through the law of gravity, is 9.8. I say 9.8. You could have easily put 10 here. This is just to give a rough scale of what we would expect things to be. So in order for something to accelerate downwards with 9.8 meters per second squared, if it has 1 kilogram, it would need to be charged by about 1/10 of a coulomb. Now that doesn't sound much, but that is like a lot. 0.1 coulomb is a lot. To give you an idea of how a lot this is, if you get one of those clingy socks, like that likes to stick to things already, that I have even had stick to my laundry basket, right? Those have about 10 to the minus 7 coulomb. So this is 1,000,000 times, let me emphasize that this is 1,000,000 times more charged than that. That is a lot of charge, and yet we see no charge effects from falling objects. We don't see discharge sparks. We don't see two falling objects attracting each other or repulsing each other, which they should do if it was due to electrostatics. It should be different for every material, because different materials hold charges differently well. Metals should hold almost, depending on how we see it, but they hold very little charge, where isolators like, styrofoam would hold a lot of charge. It would be totally depending on the surroundings. If it would be close to a mountain, it would be super different than if it was like out in the fields with little geography around. They should fall way slower indoors, because actually, in case you didn't know, electric fields, they can be shielded extremely well, and your typical house or a car or things like that would do that immediately. Things shouldn't fall inside Faraday cages anymore. It's just complete errant nonsense. Like, it's so wrong. Like, you don't need to be a physicist. I'll get my astronomy degree in September, and I will get my master's degree, and I will get my physics master's degree about in a year's time ish, right? I've completed all of the courses I need to do my master's thesis, which I've just started with this month, last month actually. And yeah, so you don't need to have any of these credentials. You can do that coming out of high school and with a bit of research, which Shane clearly didn't do. It's so funny. It's so wrong. I love it. So Shane has no clue. What about buoyancy? Well, the total force for buoyancy is, or the resulting force, really, if you want to know if it actually sinks or rises, is gravity minus the buoyant force. You could switch those signs around. It's depending on where you define which direction to be, which is, oh, well, would you look at that? G(m)(m)(r) squared. That's our old friend, the law of gravity, minus the pressure of the fluid times the displaced volume, which is this Vd here, and then G again back here. So yeah, philosophers cannot explain gravity in the slightest, because if they say buoyancy, they just mean gravity. This is a globe prediction. Buoyancy is a prediction based on gravity interacting with fluids. That's it. I've never ever seen a numerical example of where they could show that this disagrees with the globe. And until they give me a prediction, they do not have an actual model. They do. I mean, they don't. We all know that they don't, right? Yeah. So, and they actually use globe numbers every time they do their math, just as Shane has done today. So again, Shane has no clue. Which is the last slide from this slideshow, and this is also the end of the video. I hope you enjoyed this one today. I had a lot of fun making it, because when I saw this video, I thought it would be something completely different, and when I started thinking about it for like 2 minutes, I realized that Shane actually confirms globe numbers, and I can derive them, and I love it. Yeah, so with that, I hope you enjoyed this video. I certainly did. If you enjoyed it a lot, maybe consider leaving a like. If you enjoyed it a lot, maybe considering subscribing. We've just broken last week through the 100 subscribers. I'm very, very thankful for that. I thank you all for being here, and I hope you're gonna stick around if there is a lot more to come, I think. I hope. I don't know. I think. Yeah, anyway, we'll see you in the next video. Have a nice time until then.